In this video, we are going to discuss how to construct a velocity diagram for a slider crank mechanism. So this is the slider crank mechanism and all the dimensions are given, and also a particular configuration of the slider crank mechanism is given by giving this crank angle as 45 degree. Okay, so with these information we can construct the configuration diagram or position analysis. We can perform position analysis, and in addition to that, two informations are given. One is omega 2, which is the angular velocity of link 2. Okay, so that's why it's been denoted as omega 2. Okay, and that is equal to 10 radian per second. Okay, and if in case they have given it is in rpm or in some other unit, we have to convert that into radian per second. Only then if we multiply omega into this r will provide us the velocity of this point B. Okay, so we have to convert omega into radian per second. Okay, now for this that's one information. Another information is alpha 2 is equal to 0. Alpha of this the angular acceleration of link 2 is 0. Okay, which means angular velocity is constant. Okay, now with these informations we need to construct the velocity diagram. So for that, what we need to do is we need to construct we need to know the velocity of at least 2 points in each body or in each link. Once we construct that, then with that information we can identify the velocity of any body in the link. Okay, so if you see point A, the point A has which has been shared in link 1 as well as in link 2, and that has 0 velocity. Okay, so in our velocity diagram, which is given here, okay, so this is that point. Okay, so that's the origin. Okay, so we can put a point somewhere and consider that as an origin. Okay, here this length sorry, not this one, forget about this picture, this one. Okay, this is the velocity diagram. Okay, so it's been mentioned as a1 comma a2. So a1 to represent the velocity of point A, which belongs to link 1, and velocity of point B, which belongs to link 2, has been represented as a2. Okay, O is just to represent that it's the origin. Okay, now with this information we need to calculate the velocity of B. Okay, so to identify the velocity of B, we know the relative velocity equation, which is VB is equal to VA plus, and the relative velocity term, omega cross RB slash A, and omega of that particular body, which is omega 2, because we are talking about link 2, right? Therefore we know this length and we know the angular velocity, so we know the magnitude of that velocity B. We also know the direction because it's counterclockwise, so it's going to be in this direction. Okay, so with that information I could construct this vector to represent the velocity of point B. Okay, and once again, if you notice, B belongs to link 2 as well as link 3, therefore we have given it like B2 comma B3. Okay, now what do we need is we need to identify the velocity of point C. Okay, fine. So the point C belongs to link 3, and from that understanding I am going to construct or I am going to use the relative velocity between point B and C. Okay, so that will result in the relative velocity form, which is omega 3. Okay, the omega, which is the omega of this link, omega 3 cross RC/B, right? And that is going to be perpendicular to this line. Okay, that's going to be perpendicular to this line, but that's all I know, because I do not know omega 3, right? So what I'm going to do, I'm just going to draw a line perpendicular to this line. Okay, this is the configuration picture, and so I'm going to draw a line perpendicular to this line. Okay, and somewhere in this line I'm going to have my C3 and C4. Okay, now look at the point C from point A. Okay, look at the point C from point A, and when you do that, what you will observe is the relative velocity will be, they don't belong to the same body. Okay, they don't belong to the same rigid body, because this is in link 4 and this is in link 1 or 2. Okay, so now what will happen, this point C will have a velocity, it's a slider, so it will have a velocity only in this direction. Okay, so with that information, what I'm going to do is I'm going to draw a line which is in the direction of AC. Okay, so somewhere in this line I'm going to have my velocity of point C. Okay, so when this line and this line intersects, and that is the point where I will have my C4 or C3, because the point belongs to both link 3 as well as link 4. Okay, and the velocity is common, right? So that's how I construct the velocity diagram, and with this velocity diagram I can calculate what is the velocity of the slider. Okay, and if you see here, the arrow mark is in this direction from here to here, which means the slider is moving in this direction at this moment. Okay, that is obvious, because omega is in this direction, then obviously it will go from here to here. Okay, and you could also try by putting this omega in the opposite direction and shake the slider. Okay, so that's how we construct the velocity diagram, and we will identify velocity of each point in the body. Thank you.